So the webinar topic for today is maintenance optimization, moving to condition-based maintenance. Before we get started, I wanted to walk you guys through some housekeeping items. So next slide, please. So as the webinar is going, make sure that you're muted. If you have any questions though, please enter them in the chat. We'll answer them as the webinar goes along and then also answer them in the end. If you need any technical assistance, you can reach out to me directly at my email provided here. And then lastly, this session will be recorded and shared with you after the webinar. So for this discussion today, we have with us Ibose Okondo, who's the business consultant for Proficy Software and Services. We also have Oscar Montoya, who's our business consultant at Proficy Software and Services as well. With that, I'm going to pass it to our speaker, Oscar.
Okay. Good morning, everyone. Thanks for your time. So today we are going to cover the condition-based maintenance strategy, and we'll follow this agenda. So we want to present you with the tools for monitoring and data collection from those assets, and also the tool to read the anomaly detection in that data. And with these tools, you will be able to create work orders and take actions in your maintenance. And finally, we'll have a time for questions. So this story within the maintenance field starts with unplanned events. So when we have an unplanned event, an outage, a downtime, we always ask what happened and why we had that problem. And that's where we turn our attention to the future in terms of asking questions like, can we predict or can we prevent that type of events? And then within the condition-based maintenance strategy, we have this workflow, starting with installing the sensors in your assets and then monitoring and collecting that data. And we in GE Vernova, we provide with the tools like our Proficy HMI SCADA plus Historian, and that enable you to monitor and collect all that data that is going to provide you with insights from your asset health. And also, once you have that data collected into your Historian, it will give you the ability to give contextualization of the data. And also with Proficy Sense, you will have another tool to identify those anomalies. And then from there, with these two tools, you can enable for proactive maintenance. And then in that way, you can, with planned time, you can create work orders and perform the maintenance. So for the first part of the workflow, which is about machine health, we provide with the Proficy HMI SCADA and Historian, and also we have out-of-the-box tools that will visualize the data in terms of trends, alarms and events, and also the ability to access the data remotely almost anywhere by visualizing the data from a web browser like Chrome or Edge. And as long as your computer is connected to the server, you will have the visualization of that data.
So now to carry on, good day everyone. My name is Ibose Okondo, and my focus is on our C-Sense product. And from this step here, that is really the next phase of the condition-based maintenance workflow. Now, for any analytics deployment that you want to do, it is very important that you have the data foundation, which Oscar already went over, where you're getting your data and storing either in a Historian database using your SCADA SQL server. The idea is your data foundation is already set for you to easily layer on analytics to take a look at your historical data that you've saved and pinpoint anomalies and areas of variation using your data. Specifically, the product that we have, please go to the next slide. The product that we have called C-Sense is an industrial analytics product that allows you to ingest and import your data from a variety of data sources. So it could be historian or it could be your SCADA database, like we're talking about in this instance. But you can connect to OPC UA server, you can pull data from relational databases, from all these data sources, and you're able to use the models that you have within C-Sense to help you to identify areas of anomaly. Within C-Sense, you're able to build these models using the troubleshooter to manually find the areas of anomaly within a data set, or you can also use the architect to build these models to help do this anomaly detection. But we within the GE team have also created out-of-box embedded analytics that helps to speed up the process for industrial analytics. So instead of going into the troubleshooter in this instance that you see on here to manually import your data sets, to manually look for the areas of anomaly, we have this out-of-box analytics where you simply configure and point and pull in the specific variables that you want to detect anomaly for. This template is basically pre-configured, and all you would have to do is write the Python script to save your data, points to the right variables you want to detect anomaly for, and you're able to, in the last red on this trend card that you're seeing right now, the last one is that anomaly that is detected from the data sets. So what C-Sense did in this example is the first three trends, the blue line is pressure variables that we got from our historian. Then we got speed variables as well that we got in red. And then the green trend is the temperature that we pulled from our historian or from our SCADA database. Now, on first glance, we can see that clearly there is some anomaly on the temperature on the left side that shows that it went way out of this thing. The temperature went way higher than expected. But there were other anomalies in the data sets that were not obvious to like our naked eye. And C-Sense was able to take a look at that historical data set and pull and find the areas that those data didn't make sense and basically went way out of spec. You can do this for multiple data sets in this example, like I did. You can do this for single data sets. You can do this for a specific asset where you're analyzing a whole asset at once, which is what we did in this instance. And then the advancement to it is we have Operations Hub that is a visualization tool that allows you to build and create work orders. So in the next slide, Oscar, can switch there real quick. Right. So the close of the story is after you have C-Sense that helps you to determine and find and detect the anomalies like we just showed in the previous slide. Now you can enable your maintenance staff, your maintenance operators or different operators to take action. There are two forms of action that can be taken with industrial analytics solution like C-Sense, where C-Sense can actually be deployed in a closed loop implementation, where if you want C-Sense to take the maintenance action, maybe shut down an equipment, maybe adjust specific set points, if you're comfortable with the prediction that is done, you can then make your C-Sense be deployed in a closed loop. But before you get to that point, you can build screens in Operations Hub, and one of our applications already does this. If you've heard of Proficy for Sustainability Insights, where you actually allow operators to be able to submit work orders through Operations Hub, and you also be able to track the different actions that have been taken on these specific orders through OpsHub. Now, this could then be used and integrated maybe with other OT systems that you have, but at least with your Proficy portfolio, you're able to take advantage of getting your data consolidated in one specific location, then adding advanced analytics, and finally creating visualizations to complete the work order process. Are there any questions here so far? Now,
Yeah, I'm wondering what those work orders would look like in OpsHub.
that is a great question there, Adam. And I think the beauty of OpsHub is there is no defined work order. We can, of course, with our services team, help you to build out these work orders. But being the fact that Operations Hub is very customizable, you can build the screens on what we want the workflow of the work order to look like. And it's a combination, right, where right now you have all your data, the screenshots I showed. Oscar, if you can go back maybe 2 slides, please. One more. Yes. So right here, this is your C-Sense interface. And this is the UI you get with C-Sense. But if you want to show, like, specifically the anomaly detection, the last trend in your visual, you send this data to a SQL database or to a historian, and you can create your OpsHub screen that shows 4 different trend cards, basically. One for each of these variables you see here. One to show the pressure, to show the speed, to show the temperature, and then for the anomaly detection. And then just below that, you can build this your work order submission through OpsHub, where once an anomaly is kind of triggered on here, you can also configure alarms to be triggered along with it. So you have your alarm card built within OpsHub. You have a submission portal where once the alarm is triggered, an operator can click on that specific alarm and create a work order based on that. C-Sense can even give you the recommended reason for that alarm. So C-Sense will tell you the temperature variable is going out of spec, or you need to check the temperature tag. Those recommendations can help operators to create the work order to know where they need to kind of fine tune and where they need to focus their attention to solve the issues. Does that help answer your question a bit, Adam?
Yes, thank you.
Now, the good part also to point to C-Sense is, I mentioned you're taking a look at your historical data to determine what the initial anomalies are that were triggered on that system. But for long-term implementation, the idea is to integrate that and configure the blueprints that come with that anomaly detection model to read real-time data sources. So as your system, as your process is ongoing, the blueprints, the analytics will be able to learn from new values that are basically added to your data sources, be it your historian or SCADA data sources. And it will be able to tweak the model and be able to predict and detect anomalies better and differently as the system continues to collect more data. As more information basically is fed to C-Sense, it's able to better determine those anomalies from the data set. And this is just one use case. If you want the system to do other, if you have other KPIs that you want to improve upon, you can also do that with C-Sense. But in this specific use case for anomaly detection, it is really good if you want to do condition-based maintenance.